construction. It states that electron enters first into lower energy orbital and then higher energy orbital gets filled gradually. So we have given entire rule of Aufbau in the expression given below, that is 1s orbital is having lower energy compared to 2s, 2s orbital is having lower energy compared to 2p, 2p orbital is having lower energy compared to 3s, and 3s having lower energy compared to 3p. This order one has to follow. Now let us try to understand the configuration. For iron, you know the intake of the s orbital is 2 electron, p orbital intake is 6 electron, and d orbital intake is 10 electrons. So let us try to proceed ahead. Suppose there is an iron having atomic number of 26. It means your first electron will enter according to this rule, that will enter in 1s orbital. So we have written 1s2, then we have written 2s2, then we have written 2p6, then we have written 3s2, 3p6, 4s2 and 3d6. For the magnesium, we are having the 12 atomic number, that is given as the electronic configuration 1s2, 2s2, 2p6 and 3s2. Let us try to understand the next question, that is question 2b. Second, what is the degree of ionization? Explain the factors affecting degree of ionization. For that, first we will put up the factors. That the first factor is nature of ionic compound. For example, if there are strong electrolytes like HCl, NaOH, then it will possess higher degree of ionization. And suppose if there is a weak electrolyte like acetic acid, ammonium hydroxide, then it will have lower degree of ionization. So the first factor is nature of the ionic compound. Second thing is nature of solvent. Ionization is greater in polar solvents like water, and ionization is poor in non-polar solvents like benzene, ether, etc. Third factor that affects basically is temperature. You have to write down that ionization is greater at high temperature. The fourth thing is dilution of the solution. Whenever you are diluting solution, then ionization will always increase. So this one has to remember. So this is the entire long question that you are going to attempt with the full description of each and every factor and exploring the factor in the detail. Now look here, the next question. They have asked question 2b. Again a same format is there. There are two questions. It can be divided in group of 4 plus 3, or it can be 3 plus 4, or it can be 3 and half, 3 and half, depending on the examiner. So what is the first question? That is, they have asked what is electrochemical cell and explain the construction and working of the electrochemical cell. So what is our first task? That is, we will define the electrochemical cell. Electrochemical cell is device capable of converting chemical energy to electrical energy. Okay, so this is the first thing that you are supposed to actually define. So first task is over. We have defined electrochemical cell. Now let us go to the construction and working of the electrochemical cell. So for that we are supposed to draw the diagram, and then after diagram we will be describing each and everything in the detail. What are the parts, what do you mean by that parts, and what diagram actually consists of. Let us see that. Here is a electrochemical cell that is shown. If you see here, there is one beaker that is full of zinc sulfate solution. There is another beaker that is full of copper sulfate solution, right? So in that, what you will do, you will put up the next is your electrode. You will insert zinc strip, and here you will insert copper strip. So zinc strip is inserted in your zinc sulfate solution and copper strip is inserted in copper sulfate solution. Then you are actually connecting this to electrode through the circuit. After that, the next task is you will connect this two beaker with the help of the salt bridge. This salt bridge actually provides some special role whenever the reaction takes place. Okay, it is actually going to balance the anions from the two beakers. Then you will see here what is happening here. You can see the situation in the reaction. Some idea you will get from the diagram itself. Now see the reaction. you are having copper plus 2 plus zinc, that is going to give Zn plus 2 plus copper. It means it is clearly shown zinc is undergoing oxidation and copper is undergoing reduction. So you can see the reaction that is given at the below of the slide, that is zinc undergoes oxidation giving 2 electrons and copper undergoes reduction by accepting the 2 electrons. So entire diagram is made very clearly, and from this we can write down the description straight away. See here the construction, that is your electrochemical cell is actually consisting of electrode, salt bridge, anode and cathode, that is shown in the diagram given earlier. So what are electrodes? That are the metal strips, that is zinc and copper strips that you are inserting in the solution. Then we have salt bridge, that is U-shaped tube that contains a gel permeated with the solution of inert electrolyte. It is saturated solution of ammonium chloride. Then you can see here anode, electrode where oxidation takes place, and you can see the cathode where reduction takes place. Let us try to understand the working of the electrochemical cell. Electrochemical cell consists of two half cells. Each half cell consists of electrode and electrolyte as shown in the diagram. The two half cells may use the same electrolyte or they may have a different electrolytes. The chemical reactions in cell may involve electrolyte, electrodes or external substance. You can see here as shown in the diagram, in a full electrochemical cell, species from one half cell lose electrons to their electrode, while species from other half cell gains the electrons and actually undergoes the reduction process. The salt bridge is converted. Basically the main role of the salt bridge comes out to balance the anions. Here is some way the salt bridge importance. You can write down slight detailing of that in the 4 marks of the question. What is the role? It maintains the electrical neutrality of the solution, that is balancing of the charge is done. Let us try to take the next question, that is question 2b. In that, write the bad effects of using hard water in boiler. You know that suppose if you are using the hard water in boiler, what are the chances? Wastage of fuel may take place. It will lower the safety of boiler. The danger of boiler explosion will increase. It will shorten the lifetime of boiler and it may lead to the formation of the scale and sludge in the boiler. So these all things may happen if you are using continuously hard water in the boiler. So for that you can explore each and every point in the detail if you want, how the wastage of fuel will happen, how the boiler safety will get reduced. All the things you can discuss if you want in the 3 marks of the question. The next question that comes out to be, write the characteristics of the good paint. If you see here, they have asked the characteristics and they have asked for the differences, right? So in difference you can write down very clearly, that is paint varnish. For that you will start up with the definition. Let us discuss the first question of the question 3. Our question is of the 5 marks, it is having very high weightage. They have asked characteristics of the good paint and the difference between them. So first we will write down the characteristics. Minimum you should write 5 points, not less than that in the GTU paper. The first point, that is, it should adapt itself to temperature changes. Second thing, it should dry quickly. The third thing is, it should form hard, tough, durable film. These are the characteristics that one has to keep in mind when you are describing the good paint. It should not fade or crack due to weather changes. It should have good brushing characteristics. It should have proper viscosity. So why proper viscosity? Because it should be very easy to apply on the surface. Now let us try to understand. You have attempted the first part, that is characteristics of the good paint. So our next task is actually to define the difference. That is the most frequent question that is asked in the GTU question paper. That is the difference between paint and varnish. See, the paint, actually the first point that you will take up in the difference, that is definition. So what is the definition? It is mechanical dispersion mixture of one or more pigment in vehicle. Okay, so it means your pigments are actually mixed in the drying oil or in the vehicle. So that it is a mechanical dispersion mixture of one or more pigment in vehicle. On the same side, if you see the varnish, it is homogeneous colloidal dispersion solution of natural or synthetic resin in oil or thinner or both. It means in the varnish what is used, resin in oil or thinner or both. So these two are the definition that you are supposed to write when you are describing the difference. The second thing that you can read very clearly, paint contains pigment, varnish do not contain pigments. The third thing, that is the third difference, paint produces non-transparent film and the varnish produces transparent film. In that, resins cannot be used instead of oil in paint, but in varnish resins can be used instead of oil in varnish. Okay, so these are the main difference that one has to write. Painted surface reflect light and heat very nicely, but varnish surface do not reflect light and heat. So this one has to remember. Okay, so we can recall the difference. The first difference that you can see very clearly is it is mechanical dispersion mixture of one or more pigment in vehicle. Then in the varnish, it is homogeneous colloidal dispersion solution of natural or synthetic resins in oil or thinner or both. Paint contains pigment. Okay, varnish do not contain pigment. It produces non-transparent film. Then varnish produces transparent film. Resins cannot be used instead of oil in paint. Resins can be used instead of oil in varnish. Painted surface reflects heat and light nicely. Varnish surface do not reflect heat and light. So this is the entire complete 5 marks question that you are supposed to write down when it is asked in the examination. They have asked two lengthy things together, that is characteristics of good paint as well as the difference between paint and varnish. See the next question that is asked. Write only the chemical reactions involved for removal of temporary and permanent hardness of water in per minute process. What does it mean? That they are asking only the chemical reaction. If you understand the question, you don't have to describe the permuted process in detail, but what you are supposed to do is you are supposed to write the only chemical reactions for the permuted process for removal of temporary and permanent hardness. Now let us try to summarize the chemical reaction. You are very clearly aware that for temporary hardness, bicarbonates of calcium and magnesium are removable. So what we are doing, we are passing it the entire hard water through the sodium permutate. Sodium permutate symbol is taken as Na2P. So what happens when you are passing this hard water through the sodium permutate? The first thing that will take place is you can see the reaction CaHCO3 twice plus Na2P, that is sodium permutate, and you have calcium bicarbonate. That is going to give the chemical reaction of CaP, that is calcium permutate. Means what? Your calcium ions are getting retained on the permutate, and finally you will get the NaHCO3, that is sodium bicarbonate in the water. Okay, so this is the reaction. At the same time, if you see for the magnesium bicarbonate salt removal, that is you can pass through the tower of the sodium permutate, then you will have the chemical reaction like this. Mgp, that is magnesium ions that is responsible for the hardness, gets retained on the surface of the permutate, and you will get 2 times NaHCO3, that is bicarbonate water outside. Okay, so this is for the temporary hardness removal reactions. Now when you go for the permanent hardness of water removal reactions, then what happens? You can see very clearly here the salts responsible for the permanent hardness are calcium chloride plus you can have the sodium permutate, because what happens, your hard water is passing through the sodium permutate. So you will write here calcium chloride plus Na2P, that is going to give CaP, that is calcium ions are getting retained on the permutate bed, plus 2 times NaCl. Okay, so this is for the, you can say, permanent hardness removal of water reaction. So you can see very clearly here, calcium is getting replaced by sodium and sodium is getting replaced by calcium in the reaction. At the same time, if you see the second reaction, then you have magnesium is getting replaced by sodium and sodium is getting replaced by magnesium. So we have MgP that is going to get retained on the permutate bed, and we will have final 2 times NaCl. You can see the next third reaction, that is calcium sulfate. Calcium sulfate plus Na2P, that is going to give CaP. Okay, so you can see very clearly again calcium is getting replaced by sodium and sodium is getting replaced by calcium in the chemical reaction. So you don't have to mug up the reaction, but simply write down. If you are able to write 2 reactions, then automatically the rest 2 you will follow. You can see very clearly we have CaP, that is calcium is retained on the permutate bed, and then you have sodium sulfate. Okay, at the same time, if you see here, magnesium sulfate plus Na2P, that is going to give MgP, that is magnesium is going to get retained on the permutate bed, and finally we will have Na2SO4 in the reaction. So if we summarize the chemical reaction, that is they have asked only the chemical reaction, that is for the 5 marks in the permutate process. So you can summarize the chemical reaction. The first 2 reaction, that is basically standing for removal of temporary hardness of the water. Okay, so you are having the similar thing, calcium is replacing the sodium. If you see very clearly, you will put a calcium in place of sodium and sodium in place of calcium. So and automatically you will balance certain atoms. So for that we have written the reactions. You have calcium and magnesium here. In the next 2 reaction we have shown the reactions for the permanent hardness of water, how it can be removed in the permutate process. Again the rule remains same, calcium is going to get replaced by sodium, and then you have the hardness salt, that is the calcium and magnesium, they are retained on the bed of the permutate. Let us move ahead. Question 3C, that is state and explain the factors affecting the rate of corrosion. Now what they are asking you, state and explain. So in that our job is to state the factors and also to explain and to describe each and every factors, how it is actually affecting the corrosion rate. So what we are going to do is we are